So let's have a look at the compilation order dependencies that we now have. If we use direct entity instantiation, then the dotted lines here matter. Because before we instance an entity, we have to have compiled that entity. And that means that we would have to compile this file, for example, before we compile this one. However, by using component instantiations, we've broken that link, and we can compile the file containing E1 before we compile the files containing E2 or E3. There are other dependencies which we haven't broken, namely that we have to compile each entity before any of its corresponding architectures. So architecture A2 has to be compiled after the definition of entity E2 to which it belongs, for example. This is all well and good, but how do we tell what entities are actually going to be plugged into what components? Well, that's the job of a configuration. A configuration sits over the top of a particular level of your design and, if you like, plugs entities into components. For that reason, the configuration has to be compiled last, because it needs to have a bird's eye view of everything that's gone before it. Once the configuration in this case has decided that this entity is to be plugged into this component instantiation and this one into this one, then the design can be elaborated. Elaboration is the process of creating a static model, if you like, ready to go, whether that's ready for simulation or for synthesis. So what does a VHDL configuration actually look like? Imagine we have our entity mux2, and we also have a test bench that's going to check whether mux2 is doing what it's supposed to. We can use a components instantiation here to put the instance of mux2 into our test bench. Notice that mux2 is mentioned 4 times here on this slide, but they're not all referring to the same thing. This mux2 is referring to this component declaration. This mux2 is the name of the entity which is eventually going to be put into that placeholder. However, they're not actually the same thing. In fact, the component and the entity don't have to have the same name. This mux2 here in the architecture is referring to which entity is being implemented, so it's this one here. How do I then place the entity mux2 into the component socket? Well, I do that by writing a configuration. The configuration itself has a name, in this case CFG text mux2, and that's important because the configuration will become what I have to select when I'm trying to simulate my test bench, so I need to know what it's called. The thing it's configuring is the test bench, which is called test mux2, so it's a configuration of test mux2. And it's a configuration for the architecture bench. That's the architecture of the test bench of test mux2. Now what this configuration's job is to look around for all instances inside bench and bind all of the component instances to entities. In this case, there's just one component instance. The instance's name is M, and it's an instance of the component mux2. And we're going to say, for that instance, use the entity mux2, which is found in the current working library, in other words, the same library as test mux2, and use the architecture struct of the mux2 entity. What we're doing here is plugging an entity into the component hole in the test bench.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of Matt's webinar, everything you wanted to know about VHDL configurations, whenever you want, by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the KnowHow area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.